So I would like to give you a very quick overview about part of the work done in the GRoW project. Trust. The software tool to be sketched here has been implemented by Disy Informationssysteme, but of course has been created in a highly collaborative effort within the whole Trust project consortium with a particular support from TZW, the Technologiezentrum Wasser. So why presenting a tool for water risk management in a session about prevention of water conflicts? Yeah, because water conflicts are by far not limited to pure questions of water availability and water quantity, but can easily also arise from water use and land use questions affecting water quality. Yeah, because obviously, if you have in principle enough water, but not with the required quality you need, for instance, for drinking water or for irrigation, then a water quality issue immediately becomes a water quantity issue. And water quality can be affected by many different aspects, like, for instance, agricultural land use with much fertilizers or pesticides, for instance, by industrial water use, etc., etc. So water quality and potential water conflicts are directly linked together, and water quality is monitored and guaranteed by water risk management systems. So our goal in the Trust project, one of the goals was to provide a pragmatic but useful and usable software tool for the water safety plan approach to water risk management in order to prevent water quality problems and then water conflicts. The water safety plan approach, defined by the United Nations World Health Organization already a couple of years ago, is a guideline for systematic, continuous assessment of risks for the whole drinking water supply system. And based on that risk assessment for planning control measures, implementing control measures, reviewing the results of control measures, new assessment and risk of risks, and so on and so on. So this is a cyclic approach. And at the very heart of this approach is certainly the analysis part of risk assessment. Here we have a little exemplary schema. Risk assessment is always about identifying potential hazards to your water quality. Yeah, hazards, if we consider the catchment area, are often closely tied to the land use observed. A specific hazardous event normally has a certain expected severity of the impact and the likelihood of its occurrence. And in principle, if you have a catalog of all the geographically located hazardous events with likelihoods and severities that could happen in your catchment area, then you could aggregate them in the map in order to create a whole raw water risk map. One thing that is then still to be considered is that your groundwater and your surface water bodies typically have a certain level of vulnerability because, for instance, the soil typically has some protective function. Yeah, more or less, but always some protective layer. So these are the core concepts. We need to identify hazards. We have to think about vulnerability and protective layers, and then we can create risk maps from that. And this is what our tool basically supports. It is a web-based and geographic information system based tool which guides you through the full WSP life cycle. Not yet now, but sometime it will guide through the whole life cycle. It is based on a database management system, provides you with all the input masks to create and to assess all the data you need for the process. It then has some automated aggregation functions, and finally automatically creates the reports and documents needed. So the first step, as I mentioned already, is typically that you start with a map. You look at your land use and you identify areas, geographic areas, which can be used as hazard carriers. Yeah, because typically an hazardous event takes place at a certain place, a region, a location. So if you have specified your hazard carriers in the map, you can go to the input of concrete hazards and hazardous events, qualify them with their kind, their potential likelihood, their effects, etc., etc., either by manual input or by selecting from predefined catalogs. Then you have to characterize your protective layers or your vulnerability, which are, of course, inverse concepts, which again happened, or I was a little bit too quick. Wanted to start it here, the protective layers, which is again a map-based interaction where you specify certain locations, certain geographic areas, and then say here the protective layer is strong or weak. Yeah. Then you have the hazardous events collected. You have a map of the protective layers. And after that, you can go here and can let the system automatically create the initial raw water risk map by intersecting the accumulated risks and the protective functions. And of course, if this is all in a GIS system, you can go into the details, can check what's going on where and why, which places are there where a high risk is identified and calculated, and can from that point of view start with your measurement planning. So to sum up, the prototype that we have by now covers already significant parts of the risk assessment step at the level of the catchment area. For a full-fledged operational system, you would also need some subsequent steps, which are not so interesting from the scientific point of view, but just have to be implemented. And you have to cover the whole water supply chain, not only the catchment area, also the waterworks, for instance, and the distribution network. So the system as it is has successfully been tested and applied in our pilot sites in Lima, Peru, and in Germany. As I mentioned already, in order to have a commercial system, we need to do a couple of more technical steps, but I think the most interesting scientific parts have been done. And I should also mention that the Trust project as a whole created much more inspiring insights. There's much to see and to discover. So have a look at our exhibition booth and contact the project team. Thanks a lot.